So here is today's outline. So first of all, so I will introduce you to the flagship 2020 project. That's the Japanese national the project. And after that, so I briefly explain how we have been designing the architecture, system software, and applications in taking the co-design concept. And then CPU architecture and PostgreSQL system software briefly introduced. And after that, so finally, so I will introduce our operating system stuff that's being designed at the AICS. Actually, so I'm the not architect, no application developers. So I'm my the research topics are the system software, especially operating system, the communication layer, and the file I/O layer. Okay. And so this slide showed the overview of flagship 2020 project. That's the Japanese government project, and it has the two missions. So one is to build the Japanese the national flagship supercomputer. That's actually the replacement of K computer. So that's why we call it post-K computer. Okay. And so the second mission is to develop a wide range of HPC applications running on the post-K in order to solve these social and science issues in Japan. And so the project organization in the development of the post-K is as follows here. And so RIKEN AICS in charge of the development. And Fujitsu is a vendor partner. And we have the international collaborations to make the system software stack. And so DOE labs, JLS, it's the kind of the virtual laboratories. They consist of those the research institutes and universities. And also since last year, we have been collaborating with the French the research institute. It's called CEA. Okay. And the government selected the 9 social and scientific priority issues, and also in addition to those the issues, the 4 issues is called the exploratory issues were selected by the government. And so there are the organizations were also selected. And so the project started at 2014 fiscal year. Actually, so this is the calendar year. Okay, and so after the 1 year or almost 2 years, the basic design phase. Then so we have continued to design and implement the post-K machines. And so currently, so we are now here. And that's in the middle of design and implementation phase. And so CPU has been already designed by the Fujitsu, and so now is being implemented. And also the Fujitsu and RIKEN evaluating that CPU architecture. So here, so we have not only have the one simulator, but also, but actually we have the 2 simulators. One is developed at the Fujitsu, and the other one is developed at the RIKEN. And Fujitsu, of course, has their own the proprietary the compilers, and also so we can use the LLVM and GUI compiler. And so we can use those compilers for testing, evaluating the post-K CPU architecture. And system software stack has been also designed, and now it's being implemented. And so, actually, so the project name has the 2020, so the year 2020. So at the time start, so we the plan to provide the machine to the general users in 2020. But maybe 2 years before, we changed the schedule. And actually, the current schedule is so around 2021. So the machine would be operated in general purpose use. Okay. So that's the current plan. So RIKEN asked the R&D organizations for those 9 the issues, and actually so we got the asked to get the applications as the benchmark program, and we have the 9 the applications. So we call them the target applications. And so I do not explain too much for those the applications program, but here, so the brief descriptions are listed here. And so this is the co-design items. So the communication and file I/O, the integer performance or floating point performance, and those are our co-design items. And so we have much more applications being designed at those the organization, and but we think those the target applications are kind of representative of almost all our applications. So in terms of the computational methods and the communication patterns, and in order to design the architecture features. And so, we the Fujitsu decided to take the ARM V8A SVE architecture, and but the architecture doesn't specify the CMD length and the number of cores and so cache sizes and so on, and so those architectural parameters have been determined through the co-design of the architecture and the application the code. Okay. So this slide shows an overview of the post-K system. And so again, if you are familiar with K computer, so K consists of two types of nodes. One is a compute node, and another one is the I/O node. And all applications run on the compute node, not run on I/O node. So I/O nodes are separated from the compute nodes. But in the post-K computer, so we have two types of nodes: compute node and the compute plus I/O node. And that means all nodes are used for application program execution. Okay. And I said that the extra cores are the 2 cores or 4 cores. So 2 cores for the operating system activities are providing the batch job scheduler and also some maintenance activities are running on those two cores. And so this type of the node is also for I/O operation. So that's why two more cores are used for I/O operation. I mean the file system. Okay. And so interconnect is the topology, network topology is the same as the K computer. So 60 mesh torus interconnect. And so we will introduce a 3-level hierarchical storage system. And the first layer is the silicon disk, and that's the on this I/O node is the providing the features. So this layer provides cache for global file system, and also provides the temporary file system. So it has two types of the file system. One is the local file system for the compute node, and another one is a shared file system for a batch job. So those file systems are existing during the job execution. When the job is terminated, then the file system are gone, and then the new file system is created for the next job. And second layer is so we assume the raster-based global file system. And third layer is the storage for archive. And so K computer, so we take the file staging and file staging and in and staging out the mechanism. And that means so users must specify which files must be loaded to the I/O node. And when the application is terminated, then the generated files must be moved from the local file system to the global file system. But in a post-OK computer, so we don't assume this kind of the staging system, but also users transparently access the global access the file system in the global file system. So one of our KPIs, key performance indicators, is ease of use. So that's very important. So because this is the flagship machine in Japan, and we have to support many application users' demands. And so in the sense that the supporting software stack, so we have to provide the wide range of the applications, tools, libraries, and compilers. And so the standard Linux distribution is very important. So in K computer, the compute node, each compute node is in each compute node Linux kernel is running, and so in that sense, the applications running on Linux kernel may run on a K computer, but actually, so that the K computer is based on the Spark architecture, and unfortunately, no Linux distribution is available for the Spark architecture. So that means though if the user want to use the open source code running on the Linux kernel, but so they must port it to the K computer. And sometimes the application code has the assembly code, and it's basically the x86 code. And in that case, the users have to write the assembly code for that application in order to port it to the K computer. So that's so that's happened several times. And so now we took the ARM architecture and Linux distributors like Red Hat, SUSE, those are now supporting the Linux distribution for ARM architecture. So that means in a post-K computer, so wide range the software stack can be used. Okay. So Fujitsu will provide the Fortran, C, C++, OpenP, and Java, etc., and also the math libraries and the tuning and debugging tools. And the batch job system is the successor of the K computer. The usability is the same as K computers, the batch job system. And so a hierarchical file system will be introduced, and also parallel file system. And here's the part of the software stack. And so I will give you the operating system stuff in the following the slide. And so on top of the operating system, so low level the communication and the file I/O layers, and file manager the setting, and on top of that, the parallel programming environments like XMP, FDPS, those are developed at RIKEN. And the MPI as a communication layer, and the application-oriented file I/O will be also provided.